In this video, we present a series of bimanual, multi-point input techniques for fluidly interacting with a large display from a distance. Using the vision-based visual touchpad as our touch-sensitive surface, we can extract the entire two-dimensional shape of each hand from above the surface and then render it on the display for a more compelling experience. Additionally, the vision algorithms can label each finger with less ambiguity than other devices, which allows for more sophisticated interactions. We leverage these benefits by developing one- and two-handed interaction techniques that allow a user to efficiently manipulate content on large displays. To quickly navigate to any part of a large display, the user is presented with an active workspace that is rendered as a green transparent overlay on the display. The user's left hand appears at the top left corner of this workspace, while the right hand appears on the inside. The user can therefore coarsely position the active workspace by creating a pointing gesture with the left index finger. Since the left half of the touchpad is directly mapped to the entire display, the user can quickly position the active workspace anywhere by simply touching the corresponding touchpad location. The right hand can then be used for fine local positioning and manipulation within the active workspace. Contact information with the touchpad is used to select objects inside of the workspace, allowing objects to be positioned or rotated accurately by simple movements or rotations of the right index finger. For larger scale movements across the display, the user can hold the object with the right index finger and then asymmetrically move the entire workspace using the left index finger. The held object will then move along with the right hand, thereby maintaining its relative position inside the active workspace. To select and hold objects quickly, a user can make a 5-fingered grabbing gesture with the right hand. This causes the object closest to the center of the hand to be held within the hand, which effectively simulates a cut operation found in most graphical interfaces. To place selected objects back into the workspace, the user holds a 5-finger gesture for over 1 second. The hand then shows the grabbed objects on the tips of the fingers. A double tap gesture of a particular finger then releases the corresponding object. This grabbing gesture can be repeated in order to select and hold more than a single object. Each time a grab is performed, the closest object is placed into an empty slot of a finger starting from the thumb in a last in, first out cue. The user can resize the active workspace with a pinching gesture of the left thumb and index finger. Increasing the distance between the two fingers, the workspace becomes larger, while decreasing the distance causes the workspace to become smaller. Resizing implicitly adjusts the granularity at which right-hand manipulations are performed, allowing the user to trade off workspace size and manipulation granularity. The workspace can also be zoomed for very fine manipulations. A 3-finger pinching gesture with all fingers touching the surface of the touchpad activates zooming mode. Once activated, raising the index finger off the touchpad surface causes the workspace to zoom in, while raising the thumb causes the workspace to zoom out. In certain applications, the user may desire to perform two-handed manipulations in a symmetric manner. To accommodate this functionality, our system allows the left hand to be moved into the workspace area such that the entire touchpad maps to the active workspace for both hands. To do this, the user makes a 5-finger gesture with the left hand and quickly slides it down into the right. The left hand then smoothly transitions to the inside of the workspace. Similarly, to perform asymmetric operations, the user makes the same 5-finger gesture, but then quickly slides to the top left corner of the workspace. In many large display applications, a user may want to frequently alternate between 2 or more regions of the display. To achieve this, we allow multiple workspaces to be pinned so that their size, position, and zoom can be maintained. To pin or unpin a workspace, the user makes a pointing gesture with the left hand and double taps on the touchpad surface. Newly pinned workspaces are then created at the same position as the previously active workspace. The right hand then smoothly transitions into the pinned workspace area for manipulation operations. A ghost workspace, controlled by the left hand, can be used to change the active focus between multiple pinned workspaces based on the amount of overlap.